Even nice to see you.
Hello, Mr. Jesse Bob.
Hello. How are you?
Happening?
Not much. It's funny. I mentioned your name this morning to my wife. She absolutely remembers you. I was like, that's a blast from the past.
Amazing. Like the one time that we met, you guys came over once, right?
That's exactly right. Yeah,
Yeah, yeah, I remember that too.
I had forgotten. Not you, but the you guys
Yeah,
meeting.
yeah,
Yeah,
it's fine. You can forget me.
never.
Very cool. Hi,
Hey everyone, how's it going?
good,
Hi,
good.
Michelle.
Have we met, Jesse? I feel like I worked with you on something.
Yeah, I didn't want to be too presumptive. I absolutely remember meeting you, but I don't remember where.
Yeah, I was like, I know your face and
Yeah.
I know your voice. So
Yeah, probably just CNCF Kubernetes-ish things, probably. Yeah,
cool. Good.
yeah. Nice to see you.
Nice to see you too. Nice to meet you, Stephen.
Nice to meet you too. Hi, everybody. I'll give it a couple more minutes. Thanks everyone for joining today and offering to present as well. Well, it's really official if Tag Runtime's joining. I think he's switching the Zoom account. Um, put the agenda doc in the chat if you wouldn't mind just adding your name in to the attendance. That should link to today, hopefully. Oops. All right, cool. Yeah, so why don't we go ahead and get started? Thank you everyone for joining Tag Runtime today, November 21st. We have two presentations today. One for KRO. Is it a crow or is it a KRO?
We like to think of it as a crow. We
Yeah,
call it crow.
sure. Excellent. And then we have Spin and Spin Cube as well. So with the two presentations, please try to keep it around 25 minutes if you don't mind to leave time. We only have an hour today. So with two on the agenda, if that's not enough time, you're welcome to come back later and finish it out if that makes sense. Um, and if that works, you can always add yourself to a future agenda. Feel free to come back. We'd love to have you. All right, with that, let's turn it over to Crow to start us off today.
Cool. So first of all, I want to set the bar low for ourselves. We don't really have a prepared presentation. We got the invite. We're so appreciative. So thanks for having us. I can set some context and I can kind of explain what the project is, what state it's in right now, and then we can just talk about it. I had thought that maybe we would maybe do a demo and walk through sort of how it works and then just kind of field some questions. Probably will leave enough room in your agenda for for the much likely more polished presentation to come. So I'm Jesse Butler. I'm a principal product manager in the EKS team at AWS. I'm joined by my colleague who I'll introduce. So Amin Hilali, who's an engineer and is sort of the initiator of the project and the author of most of its code. So Amin and I were talking a while ago, pretty informally, about just growing conversation amongst our customers, and then also just folks that we know in the community, and people we had been at a KubeCon. I think it was last year's KubeCon NA. Yeah, it was. We were in an airport, and we were talking about how super cool the KRM is, the resource model, and how building with Kubernetes goes beyond what people usually get out of like that first experience of, oh, here's a deployment, here's a service. Like building with Kubernetes is actually embracing it as your platform and speaking its language and building things like operators, like custom resources, custom resource definitions to drive custom resource creation and lifecycle management, and then like controllers to actually build out the functionality of your clusters. At AWS, we have a lot of customers that use Kubernetes as like a foundational part of a platform effort. But I think it's everywhere from 0 to 1,000 on complexity level. At the root, there's a difference between building, deploying applications and building with Kubernetes. So we were talking about how to make that easier. And it's like, yeah, sure, just like write a couple of good blogs and a book on writing controllers. People have already done that, right? There's great books out there. So we thought, well, how do we make it easier? And we had sort of veered into this world of resource orchestration, cloud resource orchestration through custom operators with our ACK project. So that's AWS controllers for Kubernetes. All of the big CSPs have their own, right? Google has KCC, Azure has ASO, we have ACK, and these are like controllers and Kubernetes extensions to drive cloud resource management, right? Like, yes, you have a deployment and a service. What if you need a Redis cache? What if you need a database instance, right? So these are a sort of a native way to do infrastructure as code. That's infrastructure as Kubernetes config. And we looked at that and said, well, it'd be really cool to be able to sort of have a single building block that's like web app. Like, what if an application developer could come along and just have a simple, like 6 lines of YAML where they say, well, this is the name and this is the version, and all the other things fill in. You get a deployment, a service, an ingress, a database instance, a cache, right? All managed in the cloud, Azure, GCP, or on-prem, or on AWS. So that was sort of the seed we planted. And Amin went off and came back like 4 days later and went, what do you think of this? And he had written some code and he wrote a doc and he said, this, I think, is the way to do this. With Crow, which we just launched last week, and it's 0.1, it's very early days. What we're doing is we're trying to solve for that general problem of managing multiple resources, injecting configuration, timing of, what if you want a terminated load balancer as part of this kind of building block? You need to go get a cert and then get some metadata out of that config and inject it into the load balancer you config. Like, how do you organize all of that? And so that's sort of the problem scope we took on. And we think we have a pretty cool idea on how to do it. We can talk a little bit more about the details, but the general idea is to introduce a single new custom resource called the resource group. And in that resource group, someone who wants to invent one of these building blocks specifies their resources, specifies configuration, and specifies of that configuration what might be mutable and what is not mutable, or what can be set when you instantiate an instance of it. And then you can share it with your friends and family, and you can instantiate instances of this in any Kubernetes cluster, wherever it runs. It's just native Kubernetes. And so what that allows for is pretty complex. I mean, we keep finding new use cases like, oh, you could do this and you could do that. There's a lot of implied creative complexity in what we think is a simple solution that we're offering. So that's sort of the nutshell. We can see maybe a demo to see it in motion. If that's interesting, I'll just stop here, and Stephen, you have a hand up. Any other questions? Sure, kind of at a high level. or a
It-
deep level, whatever
yeah.
you want.
Is this cloud specific in some way, or does this, you said wherever Kubernetes
In
clusters,
no way.
but you also
Yeah.
load balancers as well. So how does that fit together?
So how that would work, and that was sort of an abstract use case. The the idea is that any resource can be part of a resource group. So it could be deployments and ingresses, like I said, services, native types, the kinds, but also any controller you have, any custom resource definition aligned with another controller and operator, right? Following the operator pattern. So it can work with, for example, if you have, sort of some on-prem networking hard equipment that you can provision load balancers out with an API, and there's an SDK, and you write a custom controller, and you're like, oh look, now I can in Kubernetes create a resource that represents that load balancer. You could use that with Crow as well, or you could use it with Azure, AWS, any cloud. So effectively, it's any resource. Talking about load balancers or web applications with database instances provisioned right alongside the service and deployment, that's just sort of a use case. It's an outcome of being able to assemble any resources. It installs anywhere. You can run it Unkind on your laptop. It doesn't have any dependencies beyond that. So no, it's no cloud specific, certainly no AWS specific stuff. That's why we put it out there as open source, because we think the idea is really cool and wanted to share it. Any other high level questions? I might just because I don't have slides, I might just give it to Amin, and we'll make like we prepared a demo, because he's smart and he'll just do that.
Just maybe briefly, does it like, do you install it to the cluster that you're managing? Like, you install it to every cluster basically, or yeah.
Yeah, Crow itself is an operator. So
Yeah.
the custom resource it defines, it has just the one API extension, which is resource group, and it has a dedicated controller to manage events on that resource type. What we think is cool is that the resource group you define, for example, web app resource group, right? You just create a resource group called web app, and in it you have a deployment, a service, and an ingress, right? We just keep cloud resources and load balancers out of it. So when you create that resource group, you install that, you kind of create it with Crow. Crow is running as a controller. You define the resource group, you kind of create that CRD, and Crow itself will then dynamically create a new CRD for you called, for example, web app. That new CRD gets installed and registered in the cluster, and it will then also deploy a dedicated microcontroller to manage events on that new CRD. So it's less about kind of taking the complexity and abstracting it and sort of like gluing together CRDs and other controllers, and it's more about a completely different approach, where you define this one resource group definition, and we automatically under the covers create a CRD, register it, and deploy a dedicated controller. Does that make sense?
Think
Hopefully it
so.
makes sense.
Yes.
Okay,
Yeah.
cool.
Why don't we, let's
Yeah, we'll look at stuff.
love to see it. Yeah.
Let me unmute. So I just want to like show what Jesse is talking about visually here. So like imagine in your I don't know, organization, you want to create this new abstraction called application, and all you want users to do is to provide a name and whether the ingress is enabled or not, and an image as well. Like we don't have a field image in here, like, but let's say you want them to also provide the full image URL, or like where is it stored in the OCR registry. Typically, if you want to like manage this new application, you have to create a CRD, you have to build a controller. You have to develop a controller using, I don't know, a controller runtime or operator SDK, and then you have to deploy it into your cluster, and you have to listen to this kind of events to manage them. With Crow, it's a different approach. You don't deploy a controller for each new CRD. You literally just configure the controller to watch new CRDs. And in this case, like if you wanted to, let's say, expose this new application abstraction thingy, and behind the scenes you want a deployment, a service, and ingress, what you would do is, Jesse was talking about resource groups. So there's only one concept in Crow. There's like, how can I group resources together? So there's only one CRD in here. You'll name it my application, and you're gonna be like, hey, here is what the user should be consuming and seeing. So for example, you'll be like, hey, I want you to deploy a V1 Alpha 1 kind application. Here are the spec fields, the users that can like put in the CR. So like you can see name in here, ingress enabled, and we didn't show the image because it has the default. So behind the scene, this is an open API spec. It's an open API spec, just written differently. It's made, let's say, for human beings. For us, like, so it's like it's easy to write and to to read and to write and to maintain. On the other hand, you can also configure the controller to inject some status fields after everything is ready. So you can see here, we're using cell expressions to be like, hey, go execute these cell expressions to pick the deployment conditions and available replicas. It's just like two examples, but you can literally point to any resource in that group of resources. And here, like, is your output. So this is like the inputs, the spec fields, and your output is going to be a deployment. And you can see here we're defining a deployment, and we're using cell again to be like, hey, I want you to use the user input spec.name. So the schema, we're using the schema to navigate what the user have provided. And in this case, we're using the spec.name, and we're also using the spec.image. You can also do it for ports. It's just like for this example, there is no variable called ports. You can do the same thing for replicas. It gets interesting when you have more resources, and you can see in this case, we want to put a service, and we want to like avoid making mistakes regarding like label selectors. So we can use cell again and be like, hey, just point to the deployment, go to the spec selector, match labels, and inject them in here. So now you're creating basically a dependency between two resources and saying like, hey, go and create a deployment first, then pick the labels and inject them in here. And same thing for ingress. You can see that we have a basic ingress in here. I think behind the scenes, this one is an ALB. And you can, again, use this service name that was already like generated in here. What is it? It's this one. So you can be like, hey, just go and use the service name. So you're connecting the ingress to the service. We have like this like simple directive called include when. So basically, hey, include this resource when the user really enables the ingress. So you can choose whether you want to like enable the ingress or not. This is it in a nutshell. So once you do this, you submit it to the cluster. Crow will go and validate everything. So like make sure that you really have those resources in your cluster. Let's say you had another CRD that like they're using like a CRD that doesn't exist in the cluster. Crow will tell you like, hey, this is not valid. It's gonna like also like do some type checking, make sure that like app is really a string, like it should take a string and you provided a string. It's gonna do things like, hey, what is my topological order, for example? It tells you like, even if you reverse the order, it's gonna tell you like, hey, this is the correct order to deploy your application. And once you have this and the state is active, Crow will configure itself to watch your new CRD in the cluster. And by watching, it's going to be like, hey, if you give me applications, I'm going to go and execute whatever you ask me to do in the resource group. Any questions before? I can show this in a demo, but I want to take a question as well if there are any. Okay, maybe it's demo time then. Let me share my screen real quick, like my other terminal.
So like a different question.
Mhm.
What's the plan for the project and with the CNCF?
Oh, I can answer that right before we dig into the demo. And let's keep an eye on the time too. So right now, so we've kind of been talking informally with other open source team members, primarily at a couple of our end user like companies and also at GCP and Azure. And everybody's interested in solving this problem in slightly different ways. So we've been talking about how we can possibly kind of bring everybody together, and that's been going really well. So ideally, I think what we'd like to do is kind of align all of our requirements, sort of define sort of a scope of a proposal, and see if we can kind of get one single implementation together to kind of, I mean, ideally, yeah, bring into the sandbox at some point. But that's sort of this is early days for us, but like, yeah, that's kind of the vision.
Awesome. Yeah, I think it might be also very helpful for other folks, not just the cloud providers, but I think getting the buy-in from the other cloud providers is a great first step. Yeah, thanks.
Yeah, we did have an engineer from Autodesk cut a PR and got merged like in the first few days. I was really excited about that. It's always nice to be like at a big company and have another like an external person want to contribute. So we're really excited about that.
Yep, awesome.
Yeah, I just want to point, like, we open sourced this is it Tuesday? I think it was like, yeah, the Tuesday before KubeCon. So it's pretty fresh, pretty new.
At KubeCon, Tuesday at
at-
KubeCon.
Yeah.
Was a
The
little
Tuesday of
crazy.
the KubeCon week, yeah.
Fairly fresh then, yes. Just, yeah, quick time check. We have about 9 minutes for you.
Yeah, I'll do like 2 minutes demo real quick. Whatever I was talking about, like, hey, I have a resource group in here. You can see it's the same thing that we've seen in the website. So this is a resource group, and you can see if I do, hey, give me all the resource groups, I can see that I have my application in here. And if I do -O there's a topological order. I just created this 14 minutes ago. So behind the scenes, like, there will be a CRD. So if I check the CRDs and I do a grep pro, I should see, I have my resource group one, and then Crow created a CRD for me to manage this new application. So now if I go and do an instance of that resource group, I can see, so if I do get applications, I can see that it's in progress, it's not synced yet, and eventually it will be. Okay, now it's synced, and if I go and check, hey, what's my deployment? It's there, it's been created 16 seconds ago. And if I do a get service and ingress, I should see 2 of them. Okay, I have my ingress in here. It's already actually exposed something. I didn't know this is going to be this fast. But yeah, these are the applications. If I go and delete the application, all my applications in here, it should just like go and clean up everything.
Just for posterity, can you just cat out the instance.yaml file?
Yes.
So this is where we see, like, this is what a developer would use, like, kind of abstracts everything away. And under the covers, you can have any number of resources. So like we said, like your own custom controllers, you could use ACK, ASO, KCC, things on-prem. You could basically use this as a nice abstraction. Again, kind of points back to, not only being more efficient, like as a small team, but also if you're looking at like platform building with Kubernetes, this is a really nice way to build your just sort of like modular discrete building blocks.
Mhm.
I'm curious, do you see like, I think a lot of people try to solve this through like GitOps ordering or like a rollout in some way, I don't know, like a umbrella chart or something that kind of does things in the right way. Like this kind of can address all of those cases, but on this kind of server side.
Yeah, that's a really good observation. So we've talked about, and we're really trying to not compare it to other things too much. But as far as like taking complexity, if you're going to abstract complexity, it's nice if it's like as small a scope as possible. So one of the things we like about this model is that you're pulling everything into the cluster. So basically at the runtime, at the coalface of actually building and managing these things, you don't have external dependencies or other managed services or other servers to deal with. Those can work, by the way, right? But we like that it pulls everything together, and you have a pretty thin wall between the complexity and the abstraction. And I think the other thing too is that this feels to me, as I've been playing with it for the last like few weeks, it feels to me to be a little bit more scoped. Like I don't want to have to chase issues with my YAML in another thing or, you know, in Terraform or whatever. Like those tools all work, but using all those tools at once can be really complicated in and of itself. We think that's why this could be interesting.
We got a hand raised from Michelle.
I was just curious, I saw something in the initial configuration around status, and I was wondering if you could kind of show like how you're using that. Unless you,
Yeah, sure. So sorry, like are you talking about this status in here?
yeah.
So
How,
yeah. Let me actually share my other terminal real quick, and I can show what does that look like exactly. So if I go and apply my instance again, and I do a get applications, okay, and do a dash o YAML, you can see that we're injecting some custom fields in here. So Crow has its own conditions and a state as well that tells you if it's active or not. But now you can inject more status fields saying like, hey, this is exactly what's in the deployment. So you can expose as many information as possible in your instance status. And that could be the ALB URL, it could be the database endpoints. You choose whatever you want to be injected in there.
okay, and what resource are you adding more status fields on? Is it the like any custom resource that you've created? Is it the resource group? Like what is the parent?
This is the instance. It's the application itself.
Gotcha. Perfect. Thank you. That's what I was looking for. Thanks.
Yeah.
Another hand from Tarun. Thanks.
Hey. Hey, great demo. I was just curious how this relates to or is complementary to Crossplane's compositions. Crossplane also has a similar concept of combining multiple resources, custom resources together and ordering them, and I've used it in the past. So I'm just curious how this relates to it.
It doesn't really relate to it. It's a really good question, and it's one that we probably need a louder answer to. The truth is that we're trying to not rock their boat. We wanted to try and solve this problem in a different way to see if it was interesting, and we think that it is. You know, looking at composite resources in Crossplane, that works really well for that solution. I think one of the questions is, you know, why would all the CSPs have a different version when Crossplane is there? Like, why do we need ACK, KCC, or ASO? And I think that is an interesting question as well. The answer to that is they're different operational models. So one is a more end-to-end blanket, almost opinionated, but like more complete solution for all platforms, including on-prem, right? They have support for like PagerDuty and like all sorts of stuff.
Right.
And ACK in particular, because that's the only project I can speak for, is more discrete. It has a different operational model. If you want to use only S3, you just install that piece. If you want to use S3 and RDS, you just install those two pieces. So operationally it's different. And that then led us to saying, well, how do we do something like XRDs without being such a big, complete UX solution and more just focused on Kubernetes principles? I have to figure out how to probably say that better, because everybody's like, are you competing? We're not trying to compete at all. What we really want to do is kind of build a primitive in Kubernetes that might be interesting to build solutions with. And we did talk with the Crossplane folks at KubeCon, and like we just sort of like I think both of us see it that way. I think we just need to be a little bit more clear about that.
Okay, yeah, thanks.
Cool. Very good. Yeah. Yes, thank you, Jesse and Amin, for Crow.
Thanks for inviting us. This was great, and I'm really looking forward to hearing about Spin. I just will say this is really early, so if you think this is interesting, please kick the tires, take a look at it, open issues, let us know kind of what else we could do with it. We're really excited about the project. Thanks for the time.
Yeah, very cool. Thanks for coming a week after open sourcing. So, all right, very cool. So let's pass it over to Kate and Michelle to talk about Spin and SpinCube.
So, hi everyone.
Hi.
And can everyone see the presentation?
Yep.
Wonderful. Okay, well, my name is Kate Goldenring. I'm a software engineer at Fermion, and also, go ahead, Michelle.
And I'm Michelle Benani. I'm a principal software engineer at Fermion.
And we are both maintainers of Spin and SpinCube, two projects that we have submitted to the CNCF as sandbox projects. And also on this call are James and Joe, who are also are from Microsoft and are also maintainers of SpinCube. So we want to just take this time to talk through the projects, and we'll start off by talking about serverless to make sure we all have the same definition of it. And then we'll talk about Spin and then SpinCube. So to start, what is serverless? You can think of it as two things. You can think of it as a type of application that is event driven. So it's triggered by something, whether it's an HTTP request, a message entering a queue, or a bucket. These applications are ephemeral, so there's shared nothing between each request, and they're stateless. You can also think of serverless as a development model, one in where the developer only focuses on business logic and the platform handles configuring stateful resources such as key value stores, databases, etc. And we think that serverless can also be thought of as functions as a service or fast. So if that's where your mind goes, that's totally cool too. Serverless has had kind of a lull in adoption after it kicked off, in part because it has a startup problem. So existing technologies that are underneath serverless today have very long cold starts. So Lambdas can take up to a second to start, same with containers. And what that means is sometimes you're waiting longer for your code to start than you are actually executing your code. And we saw that with Lambdas or micro VMs under the hood there. Containers also experience this in part because they're bloated with operational dependencies. And because of this, they're very slow to scale up and down, which is really important for serverless because you're supposed to have that dynamic function level scaling. And Datadog's state of cloud costs in 2024 found that 80% of container spend is wasted on idle resources. So what you can see from that is that we're not managing containers super well in Kubernetes, and we have a lot of resources that we can better take advantage of. And so WebAssembly is a technology that we think can make serverless faster, more secure, and highly scalable. So to mention a little bit about WebAssembly, if you're not familiar, WebAssembly can be thought of as a portable bytecode format. So I take my favorite language of choice that can compile to WebAssembly, whether that be Python, Rust, JavaScript, or Go, and I compile it down to this portable bytecode format. So it's this .wasm file that I now can run anywhere where there's a WebAssembly runtime. So I could run that in the cloud on some ARM server running Windows, or I could run that on the edge on a Linux AMD box. Anywhere where I can put that runtime, I can put that portable WebAssembly component. And so we know it's very portable. That's a clear benefit of WebAssembly, that whole write once, run anywhere story, but it's also incredibly small. So while an Express.js app may be a 300 megabyte container, as a WebAssembly component, it's about 3 megabytes. And if you use Rust, you can really toggle and bring down the artifact size to hundreds of kilobytes. And because we're thinking of WebAssembly in a serverless context, oftentimes this is a multi-tenant environment where you need each of your applications to be isolated. And WebAssembly has a really strong isolation mechanism with its sandbox, and it's sandboxed in linear memory and has something called capability-based security, which essentially means that your WebAssembly application won't have access to any host resources unless explicitly granted access to them. So no outbound HTTP calls, no file access, no accessing key value stores unless that toggle is switched in the WebAssembly runtime. And finally, the one that we're really excited about for serverless is instant startup times. So cold starts with WebAssembly will take less than a millisecond. So we saw with containers and micro VMs, that's hundreds of milliseconds. Now we have this secure, polyglot, portable technology that starts up in less than a millisecond. So WebAssembly is a developing technology, and sometimes it's hard to get access to the latest and greatest. We built Spin, an open source project, and the one that we're donating to the CNCF to make it easier for people to get started building and running these serverless event-driven WebAssembly applications. And our maintainers are highly involved in developing the standards for WebAssembly. And because of that, we're always pulling in the latest WASI interfaces and the latest and greatest from the WebAssembly component model. So the developer experience for Spin is basically these 3 commands: spin new, and I scaffold up my application in my language of choice; spin build, I now have my WebAssembly application, that .wasm file, and now spin up, I'm serving it locally. So we can go ahead and jump into a quick demo where we can check this out. So everyone can see my terminal, I'm hoping. Awesome.
Yep.
So at the spin new, I now can choose which language and what event I want to trigger my application from one of our spin templates. Here you can see we have some Redis templates and HTTP templates for triggering. And we also have several languages that we have templates for. So I'm going to go ahead and choose Go because this is a very Kubernetes oriented ecosystem. And then you just choose a name for your application. So I'm just going to say my spin app and some optional description. And then because this is triggered by an HTTP request, you can actually be even more specific and say what subroute of that request you want to trigger this specific component of your application. Because as you build up your spin applications, you may have several components a part of this same app. So I don't know, we'll just do the high endpoint. And then we can go and see our scaffolded application. So our business logic has been scaffolded out in main.go. We can go here and see that I, as a developer, didn't have to write an HTTP listener. We do that for you, the spin runtime. And it's all just here. And I put my business logic inside the handle. And so here we can just update this simple hello world to something customized, I don't know, runtime tag. And then the next thing to look at is the spin application manifest. So the spin application manifest is where you define all of the WebAssembly components that are part of your application and what triggers each of those components and what resources each of those components have access to. So ours is quite simple. We have one WebAssembly component, our my spin app component, that's triggered by an HTTP request to the subroute hi. And we can see I, as a developer, did not need to know how to compile WebAssembly to go, how to compile Go to WebAssembly. We do that for you in our scaffolding. And you can already see here the capability-based security. This application is not allowed to make any outbound HTTP requests. And we can update this to specify hosts that it can make requests to. And we also aren't giving access to files or databases because that's not what our Hello World application needs. So now our next command is that spin build command. Here we're doing that work for you of compiling from our Go application to our WebAssembly application. And now you can see we have that main.wasm. And now we do a spin up and we're serving this locally. And we can just do a curl on it at the high endpoint. And oops, sorry, curl localhost 3000. And hello runtime tag. So that was just how quickly we were able to scaffold up a serverless WebAssembly application, build it, and run it locally. And to talk about kind of the cloud native experience here, Spin has a really rich plugin system to make it easier to extend the Spin runtime. And we had some interns this past summer who were just cranking out plugins. And one of the really cool plugins, one of them Andrew put together, is an OpenTelemetry plugin so that I can literally do a Spin OTel up. And now I have all of my OpenTelemetry that Spin is emitting goes to a collector. So we can quickly show that. So the flow of that is you install plugin by doing a Spin plugins install, and you specify the name of your plugin. I just make this a little smaller. So Spin plugins install OTel, and we already have it installed. And then now we can do Spin OTel and see what we have available. We have Spin OTel setup, and then Spin OTel up and Spin OTel open are the ones we're going to do. Spin OTel setup. So this is going to set up all the containers I need to be able to create an OTel collector locally. And then Spin OTel up is the same as my spin up, but now we're running it and passing all of that telemetry to our collector. So now if we once again hit our application, let's now open telemetry, our collector, and OTel, I think it was open. And then you can choose which collector. So you can see you could use .NET Aspire, you can use Grafana, Jagger, Prometheus. Let's just go ahead and use Jagger. And you can see here already that we have one trace, if we look in here, and it's from our single request. And so we're already seeing spin the runtime, receive our request, and execute a component. And you can, as you have more complex applications, you can start looking at your tracing and your application flow like that. So just to kind of summarize there, Spin is a simple and pluggable CLI. We have templates to be able to scaffold up your application. My network, did it go out? Can y'all hear me?
You came back.
Oh, sorry.
No,
Okay.
no, you're good. It was just like half a second.
So still
Okay,
good.
great.
Yeah.
Also, I noticed your hand, Stephen, I'm happy to pause.
Oh, sorry. You're summarizing, but just kind of curious. So you're kind of serving this locally. You can do the OTel up locally as well. Is that kind of your like dev test kind of situation, and then you would deploy this to a cluster for something else remotely?
Exactly. So we're kind of, as we're going through this presentation, we're walking through that experience of my Spin local experience. And then I'm actually going to show just momentarily how I push my application to a registry. So let's go ahead and look at that now, actually.
Well, thanks.
So in order to be able to put this in a production environment, I first need to put this in a registry, or that's kind of the cloud native way we think of this. And WebAssembly can actually be packaged into OCI artifacts just as containers can. And so Spin simplifies taking this WebAssembly application and creating the OCI artifact with a Spin registry push. And instead of using one that might have authentication, I'm just going to use ttl.sh for this. And I feel something random so that no one overwrites it. But I can do a Spin registry push, and now it's pushing my Spin application as an OCI artifact up to this registry where it's hosted. And this can be any container registry, whether that's GHCR, Azure Container Registry, et cetera. And then Michelle later will show running this application in Kubernetes.
Does that by chance also do the OTel portion that you had enabled locally?
So the OTel portion is just basically configuring the OTel containers locally. So the Kubernetes equivalent would just be installing open like Jagger or Prometheus or Grafana in your cluster.
Okay, cool.
So, and part of that is integrating with what you already have. So a lot of people already have collectors configured in their cluster. So then you can set in variables to tell Spin what collector to eject its telemetry to.
And this is just pushing the WebAssembly binary, right?
Exactly. Yeah, it's just the WebAssembly artifacts, the .wasm files, and the spin.toml. Jesse?
Super quick question. So that's an OCI client extension that you have in your CLI. Do you have like reference type support at all? Can you do like image signing, SBOMs, any of that stuff? Have you considered that?
We don't have that built into our plugin, but it is a normal container, like a normal OCI artifact, and the same
Just an
workflows would work
image.
for that. Yeah,
That's what I thought. Okay, cool.
Michelle's done some work to kind of describe what the SBOM experience is like for Spin applications. I don't know if you want to add something to that.
Yeah, I'm actually going to drop a link for a tutorial where you can see what the workflow looks like for generating the SBOM, pushing it to a registry, scanning it, signing it with, oh my gosh, the name is slipping my mind, but I'll paste the repo in a second.
Awesome. And just to mention some of the other things we just saw there is that with Spin, we have many triggers. We saw their HTTP trigger, but we'll talk more about some of the other triggers. we have a bunch of language SDKs. So with WebAssembly, oftentimes you have to generate bindings from these WASI interfaces, and we abstract that away from you with our SDKs. So we saw the Go SDK, but we have them for Python, TypeScript, and Rust. And you can always add more SDKs. And just to mention, under the hood, like inside Spin is a WebAssembly runtime. We use Wasmtime, which is a runtime from the Bytecode Alliance, which is secure and portable, and it's always following the WASI interfaces. And Spin itself is very extensible, so you can plug in new triggers, and it's also refactorable. So the latest release of Spin included something called Spin Factors, which essentially broke up Spin into composable components so that I can actually build my own WebAssembly runtime from Spin. And that's actually what we did in the container dshim that enables us to run Spin on Kubernetes. It's pulling different parts of Spin together to create a Spin execution environment within Kubernetes. And to talk a little bit about kind of the production experience for Spin, you can access a bunch of resources from these stateless Spin applications. So I can actually do inferencing requests from Spin applications or vector DB search with our serverless AI. You can access key value stores, say you need a cache, and SQLite databases. And at runtime, you can swap in and out what the backend resource is there. And like I mentioned, there's more than just HTTP triggers. You can have Redis trigger your application, a message entering an SQS queue. You can directly invoke with our command trigger, which is great for Kubernetes sidecars. Your Spin application can be subscribed to some MQTT topic, and you can always install via plugin new triggers. So MQTT, for example, was contributed. It wasn't created by the Spin maintainers. So more and more people are starting to add more and more triggers. And with that, I'll pass it to Michelle to talk about some of our community metrics.
Thanks, Kate. Could I get share permissions? Oh, perfect. I think that's okay. Can you all see my screen okay? Okay.
Yes.
Sounds good. Okay, so Spin was first introduced as an open source project in March of 2022 by us at Fermyon. It was pretty early in the project when we first open sourced it, so very early pre 1.0. We launched a 1.0 or cut a 1.0 early in 2023. 2.0 came later that year in 2023 in November. And then we just at the beginning of this month cut a 3.0 of Spin. So we've had 3 major releases. We've got about 5,500 stars on GitHub. We keep track of a metric that we call clown loads. It's the sum of clones and downloads of the project. And we're currently at 250,000 of those cumulatively. We have about 84 contributors on the project now from various different companies, Fermyon, Microsoft, SUSE, Liquid Reply, Amazon, Mozilla, Docker, Alfalfa, Dagger, and more. So pretty excited about that. And with a bunch of new folks, we want to make sure we're on the same page around governance and decision-making and transparency and all of that good stuff. So this past summer, we worked quite a bit on our governance, our approach to governance. And what's included in our governance.md document right now is our project structure. So the Spin project consists of the core Spin repository and also different repositories containing SDKs and plugins and a few other things. Decision-making on the project is done at 2 levels. First and foremost, each repository has a set of maintainers, a set of core maintainers. They're listed in the repo at the root in a maintainers.md file. And they do all the decision-making for that specific repo. Any cross repository or project-wide decisions or non-code decisions go to a top-level governance committee. And this document also contains maintainer responsibilities and how to become a maintainer. Anybody can become a maintainer, and we're very excited about more and more people joining the project. The governance approach that we took is 2 phases. It resembles basically what Kubernetes did in the beginning. So in the beginning, there was a bootstrapping committee for the steering committee. And so we did that in phase 1, came up with a charter for this long-term steering committee, and then put in place an actual like long-term steering committee. So you can think of the governance committee as sort of a bootstrapping committee. In the next few months, we plan to make sure that we have like kind of a long-term steering committee approach with processes for elections and that kind of stuff. But what we have in the repository right now is a transparent view of how decisions are made and how the project works today. And we plan to evolve that in the next few months again. So switching gears a little bit, let's talk about what actually happens when we want to run a workload, a Spin workload at scale or in a cloud environment. Currently, you can run Spin workloads today in a wide variety of environments, from your local machine to the edge to whatever cloud. And we do have a current AKS marketplace offering, so you can do a few click-throughs in the AKS world and in their UI, and then create a cluster that has SpinCube already installed. We're also working on the same offering for GKE. And SpinCube essentially is a project that we launched earlier this year, in March of this year. And it is a combination of a few different projects that were brought together by 4 different companies. So Microsoft, Fermyon, SUSE, and Liquid Reply. It allows you to run Spin applications in a wide variety of Kubernetes environments. And the idea is to reduce the barrier to running WASM on Kubernetes. So the 4 main projects of this stack include the Spin operator, which is an operator to deploy Spin applications. It also contains the Containerd shim Spin, which was started by the Microsoft folks, developed by the Microsoft folks. It's essentially a Containerd shim for running Spin apps. And we have a runtime class manager, which is an operator. It's a way to install and manage the shim. And we also have a SpinCube plugin, and this plugin you can use for scaffolding Spin app custom resources. What Kate took us through is what you can see at the top of this particular slide. We went through the Spin new, Spin build, and Spin registry push experience. So the next steps to getting your app running in Kubernetes is to install the SpinCube stack. And then you can do SpinCube scaffold, which will scaffold the custom resource for you, and then you just apply that into your cluster. Obviously, you don't have to use the CLI. You can use whatever GitOps workflow you have or whatever deployment workflow you have currently. So the way to do that is to use the SpinCube scaffold plugin. Y'all can still see can you see my terminal now?
Yep.
Okay. And Kate, remind me what your image was called, or what your artifact was called.
My WASM app. Oh, actually, great question. I thought it was my Spin app. Yep, my Spin app 234. The tag. Yep, that's it.
Cool. Okay, so you can pass in some remote reference to your Spin app artifacts, and then you can output the YAML to spin.yaml. And we'll just cat that. So you have a pretty simple custom resource. This can get pretty complex, but Kate is going to show you how complex it can get later with all your production features. This is a pretty simple version. We're going to apply this to our cluster. And I have Spin already running, so you can see that my Spin app has been applied. If I look at what was actually created, you can see that there was a service and 2 Spin pods. And if I port forward to the service, I think that's the right. I always mess up the port forward command, so I'm glad that that's right this time. And you had the high endpoint. So here you can see that we are running Kate's remote application in Kubernetes.
Awesome. Maybe this is a spicy question, but how do you keep the same instant startup time through the Containerd shim, or does that have a different startup characteristic?
Yeah, that's a really good question. Kate or Joe, do you want to take that from a shim perspective?
Sure. So what the shim is actually doing is it's basically doing the equivalent of a spin up when you run your pod. That is a spin up instance. You can think of it that way. When we talk about WebAssembly startup time, the thing we're excited about is each time you issue a request, that is when we create a linear sandboxed WebAssembly component. So for each request, that's when you're getting that 7 millisecond. So the spin up time of starting your container, that's one thing. The other thing is that then from that point on, every time you hit a different endpoint or trigger a different component of your application, that's a new WebAssembly instance that's running.
Okay, so you the container stays running essentially to handle the subsequent requests.
Yeah, just like the run C shim for containers, the shim lives for the lifetime of the pod or the container.
Okay.
All
Sorry,
right.
I'm not quite getting that. So basically, you keep the shim up, but then you instantiate a WebAssembly module every time the request comes in.
Yeah, and that's the same as with Spin. So Spin is basically an event listener and a WebAssembly runtime. So just like with other serverless platforms, there's got to be something listening for the event to then execute your application. That's what Spin's doing. It has all these different triggers and event listeners, and then every time it receives that, it executes that component as a WebAssembly component. So when we were doing our example Hello World, that's what happened. It received the HTTP request and executed that WebAssembly component.
So if you have like a more complex app, then you have a bunch of WebAssembly modules, right? Okay, got it.
Exactly.
Then you could have that in a single container or like multiple containers, depending on how you want to route your application. Okay.
Exactly. You can split it into different containers or keep it all in one.
Got it. Thanks.
Great questions. Any other questions while we're here? Okay, cool. So what we saw was spin build, spin registry push, spin scaffold, spin cube scaffold, and then we applied it to our cluster. And this is an idea of how it works in Kubernetes. So you've got that spin operator running, it's watching for the spin app resource, it's generating the right resources with the right configuration, and that's how you get your spin app running. We did a case study with someone who was interested in using this, so the Zeiss group, and essentially, I'll just read their quote. Utilizing Spin WebAssembly with Spin Cube on Microsoft's Azure Kubernetes service helps us to achieve faster scalability and higher density without the need to dramatically change our operational posture. With that, we've been able to take a Kubernetes batch process of tens of thousands of orders and cut the compute cost by 60% without trading off performance. And so that was a really, really interesting exercise to do with them and to kind of learn that this would actually help them out in their environment as well to do more with the resources that they already have. SpinCube, the projects in SpinCube have about 366 stars, about 90,000, again, I think this is cloud loads, and around 46 contributors, including folks from Microsoft Fermyon, Liquid Reply, SUSE, and more.
And go ahead and keep driving here, Michelle, because we only have a couple minutes, but I just want to show what a more complex spin application would look like here, where you can use key value stores and our inferencing. And then if you go forward one slide, you can see that we're giving access to these resources in our spin application manifest. And then if we keep going, let's talk about the ways we can extend this YAML. So just like with other pods in Kubernetes, you can add annotations, you can add resource limits, you can add liveness and readiness probes. You can use autoscalers such as horizontal pod autoscaler and Kata. You can obviously use private container registries for your WebAssembly artifacts, volume mounts as well. And you can use spin concepts such as variables and runtime configuration, like swapping in and out what is behind that SQL database. And then finally, selective deployment, which we just announced a week ago, which enables you to develop as a developer your application in one local dev environment. And kind of to what you're saying, Ricardo, as a platform engineer, choose, I only want these components of my application to run here and these components run here. Maybe so some are co-located with the database and others are closer to the end user. And with that, that gets us to the top. And I know we kind of tapped out of all of our time, but I hope that gave you kind of an overview of Spin and SpinCube. And happy to answer questions if we want to go over, but also, happy to answer those offline.
Thanks, everyone.
Thank
Yeah,
you.
Thank you so much. If you wouldn't mind, can you share this presentation? We could put it in the meeting notes as well. That would be super helpful.
Yeah.
Sure. Is like Google Drive the best option for that, I'm assuming?
Probably would be good, but
Okay.
yeah.
It'll take me a bit to do that, but I'll get that in there by the end of the day.
Sure. Okay, cool. Thank you so much.
One last question at the with the CNCF is Spin applying for incubation or sandbox or
We
Spin?
applied for Sandbox for both of them. While we do feel like we meet a lot of the criteria for incubation, I guess we were thinking kind of one step at a time, maybe start with Sandbox and we can just move to incubation if the time were to come for that.
Sounds good. All right.
Yeah, and they're both on the Sandbox board today. So I think the next review is up in January sometime. So I guess stay tuned on where those fall on the list. But Spin at least is near the top of the list. So if those combine together, I think that was the feedback last time. Put those projects together. I think those should be reviewed together as well. But anything we can help with, please reach out. We'll be part of that process as well. So thanks so much for coming today. Really appreciate it.
Thanks for having us.
Awesome. So thanks to Crow, thanks to Spin and SpinCube, Kate and Michelle, Jesse, Amin. Thanks everyone else for joining and hope to see you next time.
Thank you. Bye.